Okay, so in our last class, we are discussing about the thiazines. Okay, more particularly 1,2 thiazines, 1,3 thiazines, and 1,4 thiazines. So here, the important thing you need to remember that adjacent to the sulfur, so there is a partially saturated carbon. Okay, that's what you need to remember. So that means adjacent to the sulfur, so there is a saturated carbon atom. So that means this one is saturated carbon atom. This one is saturated carbon atom. This is also a saturated carbon atom. So now the method. So the method of synthesis of 1,2 thiazines, starting with per. Okay, what is that? Per fluoro 1,3 butadiene. Okay, this is called per fluoro means there is no hydrogen. Per fluoro 1,3 butadiene. When it is treated with this is thio and this is aza. Okay, thiazyl fluoride. It is something like 4+2 cycloaddition, and this will be the product formed. Okay, and with this I will go to the next slide. Okay, I will have to go for a next slide. Okay, now it will. Okay, so the here the this is also more like here you know that this is what is called vinyl group, and this is a alkyl group. Vinyl alkyl features when it is treated with sulfoxamine. So there will be a nucleophilic substitution reaction. The bond pair or lone pair attack this carbon. This will go out, forming a intermediate like this. So this one, when it is treated with base, okay, the base is sodium hydride. So H2 and O, removal of water. It is a condensation reaction. So the product is formed one, and the formed one product is thiazonium oxide. This the O is there, no, thiazonium oxide. And these are the two methods of preparation of 1,2 thiazines. So I will go for, let's look into the 1,3 thiazines. 1,3 thiazine means sulfur and nitrogen at 1 and 3 position. So you know that this is a carbonyl compound. Adjacent carbon is called alpha halo. Halo here the halo is fluoro. So alpha halo ketones when it is treated with what is called as phosphonates. Okay, PO. Okay, ETO, ethoxy, 2 times. Okay, this functional group containing ones are called phosphonates. So that means alpha halo. Halo may be a chlorine or bromine or iodine, whatever it is. So alpha halo ketones, when it is treated with the phosphonates, so it will give you a intermediate like this. So this on treatment with base, so there will be a new bond formation between this carbon and this carbon. More particularly double bond. Wherever there is a phosphorus means you can expect a double bond formation in that one. So the obtained one is 1,3 thiazines. So one more method of preparation, it is starting with alpha beta unsaturated carbonyl compound. This is alpha beta unsaturated. Alpha beta unsaturated carbonyl compound, when it is treated with more particularly a compound called this one is called thiazo. Okay, and this one is called imine, thiazoimines. So that means alpha beta unsaturated ketones, when it is treated with thiazoimine, Here also a 4+2 cyclo addition. This is also a pericyclic reaction. So what will happen? There will be a new bond formation between this sulfur and this carbon, and this carbon and this carbon, and there will be a new double bond formation. Okay, right. Okay, so the compound is formed like this, a cyclic compound. More particularly, it's a dihydro. Why? Because it's partially saturated. So then what will happen? Removal of more particularly a substituent called at fourth position, a secondary amine is there. So this fourth position secondary amine can act as a living group, and this bond pair can come over here. This will go out, forming a product like this. Okay, so this is what 1,3 thiazine. So with this, these are the two methods of preparation of thiazines, 1,3 thiazines. We'll go to the next one, that is 1,4 thiazines. So this is 1,4 thiazines. So you know that suppose if there is no sulfur, suppose if there is no sulfur is called ammonium acetate. So up to this is ammonium acetate. This also a ammonium acetate. So that means it's a salt. So this salt on heating, what will happen? If you have any doubts, you can ask. If this salt, when it is heated, so there will be a removal of ammonium hydroxide. Then the obtained one is cyclic amide. And after this continuation, and from here to here, it is something like amide enal tautomerism. Amide enal tautomerism. Amide. Okay, amide enal tautomerism. So amide, you know that CONH is amide. This also CONH is amide. So when the adjacent bonded pair is coming over here, so this bond pair picks up this proton. So that is how the enal is formed. Okay, and transforming of this form to this form is called amide enal tautomerism, and the obtained compound is called 1,4 thiazines. So it is also possible to prepare or synthesize or manufacture or production of 1,4 thiazine, starting with a compound like this. So what will happen here? So this on treating with ammonia, so it's like condensation reaction. So there will be a removal of water. O and H2 will go out, form an NH. That formed NH1, there will be a new bond formation between the imine and then this carbonyl carbon, forming an intermediate like this. So later on, removal of water. How it will go? This bond pair can come over here. This OH picks up this proton, go out as a water. Similarly, this bond pair can come over here. This OH takes up this proton and go out as a water molecule. So this is how 1,4 thiazine is obtained. So this is about the diazines. So what and all we discussed about the diazines? We discussed about the synthesis of pyrazine, synthesis of pyrimidine, synthesis of pyridazine. Pyrazine, pyridazine, pyrimidine. All these are 2 nitrogen containing compounds at 1,2 position, 1,3 position, and in 1,4 position. So we also discuss about the sulfur and nitrogen containing diazines, that is called thiazines, 1,2 thiazine and 1,3 thiazine, and then 1,4 thiazine, more particularly the synthesis part. Okay, so with this, I will go to the next slide. Okay, so next slide. So next slide, I am talking about the triazines. So triazines means here the six-membered ring contain three nitrogens. Okay, three nitrogens at 1, 2, 3. Of course, it is also possible to have a nitrogens at 1, 2, 4, and it is also possible to have a triazines at 1, 2 and 4, 5. Anyway, later stage we will discuss other triazines, but now let's look at the 1, 2, 3, triazines. Okay, this is the one continuous nitrogen present in a six-membered ring. So here, if we are looking into the synthesis part, so this can be prepared starting with, okay, I think previously I mentioned that a five-membered ring with nitrogen at 1, 2 position is called pyrazine. Suppose this pyrazine is aminated, then it's called N-amino pyrazine. So N-amino pyrazine on oxidation. N-amino pyrazine on oxidation. So what will happen? So there will be a removal of hydrogen and there will be a cyclization, converting a five-membered ring into a six-membered ring. And this the obtained one is called 1, 2, 3 triazine. So this is one method. With this, I will go to the another method. Okay, so here what you can observe, it's a three-membered ring. So three-membered ring with N3. N3 means azide. Okay, so N3H means azide functional group. So now this is cyclopropyl azide. So if we are expanding this, it will come like this: N double bond, N plus, N double bond, N minus. This is the expanded version. Okay, and what will happen? So this cyclopropyl azide on heating rearranges, okay, giving rise to 1, 2, 3 triazines. So how it will give? So let's look into the mechanism part. This is the mechanism part. So here N3 is expanded, N double bond, N plus, double bond, N minus. It is also possible another form, but that I am not written here. One more form is possible. So since there is a positive charge here, this bond pair can sit on this nitrogen and there will be a double bond here. Okay, but then on, yes, this is the most preferred canonical form or resonance form. You can write like this only for the azide. So that means N double bond, N plus, double bond, N minus. That's only you write. Then afterwards, what will happen? You know that since there is a positive charge, this bonded pair try to move towards nitrogen and convert it as a lone pair. When there is a transformation like this nitrogen occupies a positive charge. That time, this bond pair will form a bond with this nitrogen. Since there is a positive charge on here, then this bond pair will move towards that. So what will happen? So here, this is a three-membered ring. There will be a more strain, more particularly bond strain, prolog strain, Hankel strain. Okay, because to overcome that, this is more feasible, thermodynamically favorable, and the product is formed. One is called 1, 2, 3, triazine. Okay, so with this, I will take one more method of preparation of 1, 2, 3, triazine. So here I am taking again the diphenyl cyclopropyl chloride. So diphenyl cyclopropyl chloride, when it is treated with diazomethane, I think you are aware about the diazomethane and its application. So it will act as a nucleophile and also it will act as a 1,3 dipolar addition. So here what will happen? Initially there will be a replacement of this chlorine forming a compound like this. So once after the compound formation like this, then as usual, this bond pair will come over here. This bond pair will go over here, forms a what is that lone pair on the nitrogen, and similarly this bond pair will move over there. So that is how 1 comma 3 comma triazine, diphenyl triazine is formed. Okay, these are the three methods of preparation of triazines, more particularly 1 comma 2 comma 3 triazines. So now let's go for a different triazine. So that different triazine is called 1 comma 2 comma 4. Okay, this is the one. Okay, 1 comma 2 comma 4. Okay, triazine 1 comma 2 comma 4 triazine. How this can be prepared or synthesized? You know that this type of compound is called alpha diketones. It is also yes, alpha diketone. This is the functional group, and this position is alpha, and it's called alpha diketones. This alpha diketones, when it is treated with and you know that without this uh, 2 nitrogen is called amide. If there is a O here, it's called amide. Suppose this amide is treated with the hydrazine, the obtained one is called amide hydrozones. Okay, so that means alpha diketones, when it is treated with the amide hydrogens, undergoes condensation reaction. How it will condense? So you know that this H2, this O will go out as a water. Similarly, this H2 and O will go out as a water, forming a cyclic six-membered ring containing nitrogen at 1, 2, and 4th position. And the product is 1 comma 2 comma 4 triazine. So with this I will go for a one more method of preparation of 1 comma 2 comma 4 triazines. So here I think you know that, so without NH2, suppose if there is a oxygen here, then it's called benzyl. Okay, I think you are aware about the benzylic acid rearrangement. I think you are going to prepare this particular benzyl in your laboratory, I think. Okay, it is for the third or fourth semester experiment. Okay, you will also carry out the benzylic acid rearrangement. But here, what will happen when you are taking a benzyl? Benzyl means two phenyl with two carbonyl group, CO here, CO here. That is called benzyl. So that benzyl, when it is treated with 1 mole of hydrazine, you will get benzyl monohydrazone. The obtained benzyl monohydrazone can react with urea. This is called urea. NH2CO, NH2 is in urea. So what will happen? The lone pair or the bond pair can attack this carbon. This will go out. So when it will happen? When you are mixing both of the thing and heating, it will happen. So the obtained compound is like this. Then afterwards, what will happen? So there will be a H2 and O, removal of water. Similarly, amide enol tautomerism. This bond pair is coming over here. This will go to that position, forming a 1 comma 2, 1, 2, and 4. 1 comma 2 comma 4 triazine. This is how 1 comma 2 comma 4 triazine is obtained. Overall, 1 comma 2 comma 4 triazine can be obtained starting with benzyl monohydrazone and urea on heating, undergoes condensation reaction and giving rise to 1 comma 2 comma 4 triazines. So with this, I will take one more triazine. So that is 1 comma 3 comma triazine. So you know that alkyl. Okay, so alkyl means this R may be a alkyl group. Okay, alkyl cyanide. This is called C triple bond N is called uh, cyanide. So this is one molecule, this is another molecule, this is one more. That means 3 molecule of alkyl cyanides undergo trimerization, giving rise to triazine. Okay, so this structure is wrong. Don't take it as this structure. So maybe you can take this as a structure. So that means a triazine compound is obtained like this, but here R will be there. This is also R will be there. So that's what you can write here. Okay, maybe I can correct now, but I will do it in your notes. Okay, uh, so what it means, alkyl cyanide undergo cyclotrimerization in presence of concentrated HCl, giving rise to uh, 1 comma 1 comma 3 comma and then 5, this. So here nitrogen, there nitrogen, and here nitrogen, these two nitrogens are not there. Okay, the product obtained. So this is one method. Another method for preparing 1 comma 3 comma 5 uh, triazines, you know that. So guanidine means NH2C double bond NH, NH2 is called guanidine. If the two guanidines are combined, then it's called biguanidine. So this is called biguanide, otherwise guanidine, biguanidine. So what will happen? It is nucleophilic in nature, and this bond pair can attack acid electron deficient carbonyl compound. This Cl will go out. So then what is the product form? A intermediate product is obtained like this. So later on, the lone pair or the bond pair can attack this carbon electron deficient carbon, forming a compound like this. And then later on, what will happen? It will be a aromatizing. Okay, how it will aromatize? This bond pair is coming over here. This will go out. Similarly, this bond pair will come over. This will picks up the protein. Similarly, this bond pair is coming over here. This will picks up the protein. What it means? It means that one more method of preparation of 1 comma 3 comma 5 triazine, starting with biguanidine. Biguanidine, when it is treated with acid chloride, it leads to the formation of diamino 1 comma 3 comma 5 triazine. Okay, that is about the two methods of preparation of 1 comma 2 1 comma 3 comma 5 triazine. Okay, so with this I will go to the next slide. So next is about the tetrazines. Okay, tetrazines means 4 nitrogen containing heterocyclic compounds are called tetrazines. So there are different tetrazines are available. I'm initially I am taking 1 comma 2 comma 3 comma 4 tetrazines. So if you want to prepare a 1 comma 2 comma 3 comma 4 tetrazines, so here I am taking, you know that NH2 is called hydrogen. NH2 is also a hydrogen. Since it contains two molecules, we can call it as a bis hydrogen. So bis hydrogen, when it is treated with potassium permanganate, in this reaction, potassium permanganate acts as a dehydrogenating agent, removal of H2. So one H from here, one H from here is removed, forming a double bond, N double bond N. So this is how the product 1 comma 2 comma 3 comma 4 tetrazine is obtained. Okay, so with this I will go to the next slide. So here what you can observe, look here, this group phenyl CH2 is a group is called benzyl group. So 1 benzyl, 2 benzyl, 3 benzyl, 4 benzyl. That means N comma N, we have to say that N comma N. Otherwise, what we can say that 1, 2, 3, 4. That means 1 comma 1, and here 4 comma 4 tetrabenzyl tetrazine. Okay, tetrabenzyl tetrazine. 4 nitrogens are there, and there should be a double bond here because ene is there. No, ene means there should be a double bond here. And when this is treated with KMNO4, here also it will act as a dehydrogenating removal of H2, where it will remove one H from here, another H from here, removes and forming a bond here. Okay, so that is how the product is obtained. Okay, so after this, how you can name? Only this position N comma N, otherwise 1 comma 4 dibenzyl, 5 comma 6 diphenyl. Then tetrahydro. Why it is tetrahydro? There is no double bond here. There is no double bond here. That is the reason. Tetrahydro tetrazine is the name of this product. So with this, I will go to the next slide. So next slide here, you know that one more method of preparation of tetrazines. Okay. So what will happen here? You know that this is also what you call cycloaddition, more particularly 4+2 cycloaddition. But we have to name these two compounds. You know that this NH double bond NH is called diimide. Okay. NH double bond NH is called diimide. So that diimide, when it is treated with acyl halide, so you will get a both are since there is a presence of acyl group attached to the nitrogen. So these imide, okay, diimide is called electron deficient one. And since there is a electron deficient one, it will act as a dienophile, and this will act as a diene. Okay. So what is the name of this compound? Maybe you can say that this group is called vinyl group, and this group is called aza. So vinyl aza, when it is treated with electron deficient diimide, so it will undergoes 4+2 cycloaddition, giving rise to a tetrazine. Okay, 1, 2. Here what you need to remember, don't give priority to this nitrogen, give priority to this 1, 2, 3, 4. Okay, so then 5, 6. So this is how you can numbering. Okay, right. So why I'm here mentioning, because 2, 3, 4 tetrahydro. This is the 2 position. This is the 3. This is 4. This is 5 tetrahydro. There is no double bond here. That is the reason. Okay. Then this is one more method of preparation of tetrazine. That means electron deficient diimide, or you can also say that aza compound, electron deficient aza, when it is treated with vinyl aza compounds, undergoes 4+2 cycloaddition, giving rise to tetrazines. So with this, I will go to the, I will take one more kind of tetrazine. So here what I am taking 1, 2. So that means 1, 2, 3, and then 5. So 1, 2, 3, 5 tetrazine I am taking. How we can prepare this one? So it is possible to prepare with NH2CN. NH2CN is called cyanamide. Okay, cyanamide EC reaction. EC means electrocyclic reactions. Okay, so nowadays electrocyclic reactions taking priority. Okay, so what it means, cyanamide, when it is treated with electrocyclic reactions, more particularly oxidation in presence of KOH, so giving rise to tetrazines, more particularly 1, 2, 3, 5 tetrazines. Okay. So it is also it is also possible to prepare tetrazines, more particularly 1, 2, 3, 5, starting with diazirine. Okay, azirine means nitrogen. Nitrogen with the 3-membered ring is called azirine. Since there is a 2 nitrogen, we can say that diazirine. Diazirine, when it is treated with what is the name of this compound? You can say that CH3 silyl compound, mercuric silyl compound. So this reaction in presence of light, that means it's a photochemical reaction, so forming a product like this. So this this is an intermediate. This intermediate on dimer, on it will be equilibrium with the dimer. Okay, intermediate it will be equilibrium with the dimer. Okay, so this is how one can prepare or synthesize 1 comma 2 comma 3 and comma 5 tetrazine. Okay, so with this I will go for a one more kind of tetrazine. So one more kind is 1 comma 2 and then 4 comma 5. Okay, here I will show. So 1 comma 2, 4 comma 5 tetrazines. It's also called as S tetrazines. Otherwise, it's also called as a symmetrical. Okay, symmetrical tetrazines. Okay, so what will happen here? You know that what is called as NH2. NH2 means is called hydrazine. So this NH2 hydrazine, when it is treated with acetone, it will give you acetone azine. Okay, acetone azine means this one. Acetone azine undergoes Diels order reaction. So of course, this is a dimethyl imide, diimide more particularly, dimethyl imide. Overall, what is important here? This is a conjugated diene, and this one will be the dienophile. This is here there is a 4 electron, 4 pi electron. Here the 2 pi electron undergoes cycloaddition. How it will undergo cycloaddition? This bond pair is coming over here. This bond pair go to over there. This bond pair is forming a bond here. So giving rise to a cyclic compound, and the cyclic compound is tetrazine, more particularly 1 comma 2 comma 4 comma 5 tetrazine. So this is one method. I will go to the next slide. So here I am taking a, you know that hydrazine, NH2 is called hydrazine. NH2 when it is acylated, so then what is the product obtained? Diacyl, 2-acyl group, diacyl hydrazine. Diacyl hydrazine, when it is treated with phosphorus oxychloride followed by oxidation, giving rise to 1 comma 2 comma 4 comma 5 tetrazine. This is one more method of synthesis of tetrazine, more particularly 1 comma 2 comma 4 comma 5 tetrazine, starting with the diacyl hydrazine. Diacyl hydrazine. So diacyl hydrazine, when it is treated with phosphorus oxychloride followed by oxidation, giving rise to tetrazine. So if we are looking into the mechanism, so this starting material I have written.
Sir, you are not audible, sir.
Oh. Now you check. Am I audible? Hello.
Audible, sir.
Okay, fine. So this is diacyl hydrazine. Diacyl hydrazine, you know that amide enol tautomerism. Okay, what will happen? The bonded pair is coming over here. This bond pair picks up the proton. So that's what I have written. This is the enol form and this is the amide form. This transformation is called amide enol tautomerism. And this one, when it is treated with phosphorus oxychloride, it's a chlorinating agent. It will convert 2-hydroxy group into chloro. That's what I have written here. So once after the chloro is obtained, it's a living group, and this chloro is replaced with amino because it's a nucleophile. It will react. What the lone pair can react this carbon, this Cl will go out. So that is how the product is obtained like this. And from here, removal of hydrogen. Okay, that means dehydrogenation. So the obtained compound is called 1 comma 2 comma 4 comma 5 tetrazine. So this is about the mechanism and this is the reaction. Suppose if there is a question, predict the product and write the mechanism. If they are given only this much of the information, then you should be able to write all this thing. So with this, I will go to the next slide. So next slide is about the reaction of nitrile with hydrazine. Of course, we can say about alkyl cyanide. Alkyl cyanide reacts with hydrazine, okay, undergoes dimerization, giving rise to tetrazine, more particularly 1, 2, 4, 5